In this week's lesson, we're going to talk about the data types within PostgreSQL, as well as the null value and null functions. So let's start with the data types first. One thing you should know is that every database DBMS or installation of those DBMSs have their own particular data types, specific ones that are only going to be used in that type of product. So be aware of that when you look at PostgreSQL data types as well. There are some things in here that you won't find in, for example, Microsoft SQL or Oracle, and they'll have their own ways of doing the same thing, maybe slightly different names for the data types, but accomplish the same thing. So be careful when trying to make code that's portable between database management systems, and be aware of that. So the first data type is the Boolean data type, which is basically a true or a false. And it will convert things like yes, y, t to a value of true, and things like no, n, f to a value of false. False equates to a 0 value, and true equates to a 1 value. So there's lots of good uses for Boolean types when there's only two possible states, on or off, yes or no, true or false. Boolean might be a good way to go. There are various character data types, one where you actually specify the length, some where you don't. I would use the varchar whenever possible. It's the most compatible across other different databases. Similar databases have, other databases have similar naming conventions as varchar. So be aware of that. As far as number data types, there are integers and floating points. So floating points allow decimal places, integers do not. Within integer, there is small integer, which has a range of, in this case, negative 32,768 to positive 32,767. Integer is twice that in size. It's a 4-byte value, and it has a much larger range, as you can see. Serial is one of those specialized fields, specialized data types that Postgre has that others have as well, but not named the same thing. Serial will create a auto-incrementing sequencer value that can be used as a primary key in your tables, and it's very useful to use the serial, but just know that it's not, your code won't be as portable if you use it as using some other mechanisms. Floating point numbers, there's floating type data type, which is precision, a maximum of 8 bytes. There's reals, there's numeric. I tend to use the numeric one. Again, portability seems to be common across a lot of other database management systems. Then there's temporal data types like time-based and date-based things. So date just stores date, time stores time, and then there's timestamp and other variations of that. There's also some special data types that we won't cover in this lesson here that we won't really have too much use for. So let's go over to some samples. Let's go over to the Postgre installation that I have here, and let's look at some SQL. I have a create table here that I'm creating in my own schema called MyDB. Actually, my own database called MyDB, and then a schema public. It's a table called MyTable, not very named very well. Just for demonstration purposes, you of course want to name your tables and your installations much more meaningfully. But I wanted to show you various types of columns and how to use them. So we have here a table that has people in it, and it carries a person's ID, which for me is going to be the primary key. You'll note here that the constraint is defined as the primary key, the person ID. And it was set up initially as a serial. So this was converted by PostgreSQL into an integer, not null. Okay, and the default is coming from the next value that this sequencer called MyTable person ID SEQ provides. So sequencer, again, is an ever-increasing entity starting with a certain default value that you set up when you create the sequencer. In this case, since the system is creating it, it'll use all the default values of how much it should start with, how much it should increment. You can check that out on this side here under sequencers. You can look for that as a type, as a sequence right here, and you can look at that to see how it's defined. And then I have the last name, the first name of the person. Notice I'm using the varying length character fields, a maximum of 30. I'm using a gender column as a character of 1 because gender is going to, you typically have M for male and F for female. Then you're going to have a Boolean for are they a U.S. citizen? So this is perfect for is U.S. citizen. It's a yes or a no, true or false. So that's a great example of when to use a Boolean. I'm using a date column for their date of birth. I'm using a numeric column, a maximum of 8 positions to the left of decimal place and 2 decimals for the current salary. And then I'm using a small integer to hold the number of children, because I imagine that we won't breach the size of a small integer with that. And also then I went to and inserted some values into the table using putting in nulls in some cases. You can see here that I put nulls into various of the fields. I've also put in some zeros for salary to show you how that goes. So I am going to retrieve this table here just really quickly to show you the data in it. This is what it looks like. You notice that the Boolean gets converted to true and false. Even though in the actual SQL, you notice that I use true sometimes. I use the 0 character. I used F for false. Yes, why yes. All that was converted over to true and false Boolean as it's stored in the table. Date of births are here. Some are null. There's some salaries in here that are null. Actually, one salary is 0. So we'll use all that to our advantage later. Okay, so now going back to some of the lessons for the week, we actually learned about the null value, right? Null is when a value is missing. It's not a blank for a character field. It's not a 0 for a number field. It's just missing. It's not there. So it's very different than actually having a value in there. But there are times when you need to handle nulls, that seeing a null in your output or using it may affect the results. We've learned, though, in prior lessons that for the aggregation functions like average and sum and min and max, that nulls are automatically ignored in the process. So you don't have to worry about them. They won't affect the averages or the minimums or the maximums. But there are times when you actually want to take control and where they will affect. And so let's talk about a couple functions here. There's a coalesce function, which basically says, given a list of values or arguments, return the first one that is not null. So the examples here are coalescing hard-coded values 1 and 2. The first one that's not null is 1, so it returns a 1. In this one here, you have a list of a null, 2, and 1. The first non-null in this list is the 2. So coalesce is good to use in your programming and reporting to mask out null values and provide a more meaningful output to the user. Another function is the null if function. The null if function is interesting in that it says if a value is equal to something you're comparing it to, then return a null. You're actually wanting to see a null. So, for example, when we're trying to coalesce the list of values here, right? And so right here, they're outputting the results from this table, selecting these 3 columns from posts. You'll notice there's one null value here, column ID 3. If they use the coalesce function, okay, that would allow you to return a non-null value, in this case here. But null if is interesting in that it allows you to test for null and do something different with it. So a common function or common use of that is when you have dividing by a number and you want to avoid a divide by 0 error, right? So what if the sum of something or the average of something was a 0? Returning a null down in the bottom avoids the division by 0 error and returns actually null as your result of that calculation instead. So it's a little bit nicer result of that. So if you want to read about this in more detail, I'm going to actually show you myself here in Postgre, some sample SQL. So as I showed you before, I created a table, I inserted some values. So let's look at some select statements here. So this first one here is just a simple select. I'm actually using a construct to concatenate first name and last name into a nice single column. I'm using the double pipes here, so it's 2 pipes in a row. And I'm using a comma here to separate the names with a single quote, and then the concatenation double pipe again, and then first name. And I'm naming that column as person name. Notice I'm using as a lot to alias all the columns, so my output has nice titles on top. So let's look at this one and see the output. So you have the person's name, and again, actually last name, comma, first name. And what's really nice about that is by doing it that way, if I wanted to alphabetize this, I can do it very easily by using an order by statement. And I can actually, there's several ways to do the order by here. I can say order by 1, which is the first column in the list. I can also order by the name of the column I called it, which was person name. Okay, I'm actually going to just order by 1 here and show you that since I used this kind of concatenation and ordering, the last name is first, I'm going to be able to sort this in the normal alphabetized by last name methodology. So Fred Carson comes up top and then all the way down to Sophie Williams at the bottom. Okay, so that's the first thing I want to show you. Now, let's do a little bit of math here. And let's try to figure out, given a person's salary I have on the table, notice that we have some salaries here. Some are 0, some are blank. Let's look at their monthly salary. So that would be their current salary divided by 12, right? This is an annualized salary. Let's divide it by 12 to get their monthly salary. So let's see what the output looks like there. Okay, so for most folks, it comes out with a value, but for Ted Koppel, it came out with actually no monthly salary because if you recall, his salary was blank. Okay, it was null. Not in there. I shouldn't say blank, it was null. So we're going to fix that by using the coalesce function in our next iteration of this. So rather than just doing the straight math of current salary divided by 12, I'm going to wrap the coalesce function around the numerator and say, well, if current salary is null, and that's what coalesce will test for, then provide a different value in there as well. So I'm going to say that we have a company default salary of $25,000 in this calculation I want to use. So I'm going to replace a null current salary with $25,000. So let's do this SQL statement. Let's run it. And notice now Ted Koppel has an average salary showing up because he now has a value there to use it. So that's one simple example of coalesce. There'll be a lot more complicated and more involved ones you'll be using as you use SQL more and more, but that's a simple one. So let's also talk about using some aggregation functions. We learned about the average function, okay? And we also learned how to use group bys when you're doing aggregation functions. Here I'm using another function called truncate. Truncate, if you notice the salaries down here, they have very deep levels of precision, and that kind of for dollar amounts doesn't make much sense. So I want to truncate the current salary average to 2 decimal places. Right? I want to do an average by gender, so looking at the males and females, and see what the average salary is, but I only want to show it in kind of dollar or money terms. So that would be 2 decimal places. So I'm using the average function, average current salary. I'm wrapping that within a trunc, which is short for truncate. And truncate takes one parameter, and that is how many decimal places you want to truncate to. So I'm saying, show me 2 decimal places. So let's run this. And you'll see here that the males and the females have an average salary. Females are about $870,000 and males are about $400,000. Well, one thing going back I noticed, and let's go back to the original select statement or just all the salaries and everything. You notice that I don't have a salary in here. I actually have a 0 salary in here for Fred Carson. So that's, I think, messing up these average results. I don't believe Fred is unpaid. I think Fred is paid, but his salary is entered to 0, which may have been a mistake. So what I want to do is I want to find a way to actually set that value to a null so it doesn't count in the average, right? Remember, average functions don't take nulls into account when it's making the average. So how would I do that? Well, here's how you would do that. So looking at the function we were using before was just average, okay, with the trunk around it. We're going to put the average still there, but inside of it, use the null if. So we learned about the null ifs. It says if the field or column you mentioned inside is equal to the value you have after it. In this case, if current salary is 0, then the null if is going to return a null for that value rather than the 0. And in essence, I'm going to negate the problem that zeros cause in an average function. So instead of turning a 0, it returns a null. And watch how my average changes. So again, going back to the original one without the null if, you'll notice the men's average is $405,000. So let's run this now with the null if, which would take out that one salary of 0 because it'll make it a null and average won't count it. And notice now my average salary is $607,000. because it is discounting and ignoring the zero value using the null if command. So that's some discussion and samples of using the functions we learned this week's lesson. Hopefully you found it useful, and we'll see you soon. Cheers.